With NISAR, we're tracking the changes of the solid Earth and how it's moving, ecosystems, ice cover, and any other thing that's changing at the scale of a centimeter on the Earth in a way that we've never been able to see before.
This is a partnership between NASA and the Indian Space Research Organization.
NISAR is going to be one of the most sophisticated radar satellites that has ever flown in orbit.
NISAR is going to open our eyes to seeing the ground in places that otherwise has been obscured.
NISAR will help us to better understand earthquakes, volcanoes, landslides, floods, wildfires, oil spills.
The society will also benefit due to its contribution to disaster management and providing food and water security.
These are global problems that the global community needs to come together to resolve.
Now it looks like we are no more belonging to two different worlds, and we all belong to the space community. That's it.
You are looking live at Mission Control at NASA's Jet Propulsion Laboratory in Southern California. The team here is waiting for the launch of NISAR, a powerful Earth-observing satellite built to track changes in our planet like never before. And in just an hour and 8 minutes, we are taking you to the Satish Dhawan Space Centre in Sriharikota, India, to watch NISAR launch on a GSLV rocket. Hello and welcome. I'm Raquel Villanueva, live at NASA's Jet Propulsion Laboratory, and here with me today is Dr. Sue Owen. She is part of the NISAR team and also the Deputy Chief Scientist here at JPL. Thank you for joining us today, Sue.
Thanks for having me here, Raquel. I'm really excited to be here.
Yeah, and we have teams standing by here in Mission Control and in India because NISAR is a joint mission between NASA and the Indian Space Research Organization, also known as ISRO. So, Sue, can you tell me a little bit more about that partnership?
Yes, Raquel. The NASA and ISRO partnership on NISAR is the first time that the two organizations have worked so closely on a mission, with both organizations providing major hardware contributions. And the name NISAR has the partnership right in it. It stands for NASA-ISRO Synthetic Aperture Radar, so it has the partnership and the type of measurement that NISAR will be making.
Well, I'm excited to have your expertise here today. And soon we will hand things over to our ISRO colleagues for their live coverage of the launch. With Sue here, we have a chance to answer your questions live. If you have a question, send it our way using the Ask NISAR hashtag, and we will try to answer as many as we can live. NISAR is an Earth-observing satellite set to be a game changer for how we study our planet's surface.
Yes, NISAR is going to be able to measure changes both big and small as a centimeter on the Earth's surface. It can measure surface movements caused by earthquakes, by volcanic activity and landslides. It can track changes in glaciers and the melting of ice sheets. NISAR will measure flooding caused by storms and hurricanes, and also observe how forests grow and shrink, and so much more.
You know, and Sue, let's take a moment to acknowledge just hours ago there was a major earthquake, 8.8 in magnitude in eastern Russia, and officials are still assessing injuries and damages.
Yes, and our thoughts are with the people who are impacted by this earthquake, and it's these types of events that remind us how important the types of measurements that NISAR will be making will be. They will help us to be able to forecast where these types of events occur, as well as assess the damage after these earthquakes and tsunamis.
Well, thank you so much for that update, Sue. So we will dive into the science behind NISAR a little later in the broadcast. Now let's take a look at how NISAR made its way onto the launch pad in India on a GSLV rocket.
So you can see here that NISAR is moving on to the launch pad, and this is just one of the final stages of its journey to the launch pad. NISAR has actually been traveling around the world as it's made its way here. It started both in India and in the US, with India building the SSAR and the US building the LSAR, and then the SSAR traveled to the US to be integrated, and then the integrated radar traveled back to India, and now it is making its final movements to the launch pad, getting ready to launch and travel up into space, where we'll be making the observations that will enable the science.
And as a reminder, this is a joint broadcast with ISRO, and they will cover launch, which is about an hour and 4 minutes away. And we now know what NISAR will study, but how does it actually all work? So to help break that down, we have Adrian Borsa from the NISAR science team. Adrian, thank you so much for joining us today.
Great to be here.
So for people new to this technology, how does radar allow us to see changes on Earth's surface?
Well, because NISAR is a radar mission, it is essentially operating all the time, all weather, day or night.
First is the consistency. The fact that we're going to get these incredible data very consistently every couple of weeks. The other aspect of NISAR that's very important is its wavelength. It's got a longer wavelength than most satellite missions that have taken radars up into space, and that longer wavelength means that we're going to be able to penetrate vegetation and be able to see the ground through trees. We're going to get consistency, and we're going to get the ability to see through a lot of this obscuring vegetation, and that's really going to open the door for studies of volcanoes.
Because it's expensive and dangerous to put ground sensors around many of the world's volcanoes, many volcanoes around the world have no sensors on them or too few sensors to really understand what's happening.
Having something that's completely remote and satellite-based allows us to get an image of what's going on without needing to have something in the remote ground surface.
The thing about volcanoes is they could have a regional or even a global impact depending on the size of the eruption.
So it's really key to be able to understand how volcanoes work so we can better forecast their activity and warn people that might be impacted by eruptions.
And Sue, there are other natural hazards that NISAR can monitor as well.
Yes, and just recently, in the last few hours, there was a major earthquake in Russia, magnitude 8.8, and NISAR will be very important for being able to forecast as well as assess the damage caused by those types of earthquakes and the tsunamis that they can generate as well.
Oh, thank you for breaking that down for us, Sue. And NISAR's journey to the launch pad was a global effort. JPL built the L-band radar while ISRO built the S-band. The two were integrated at JPL into a single radar payload. That system, along with the boom and reflector, was then shipped 9,000 miles to India. In Bengaluru, teams from both agencies worked together to assemble and test the satellite. After final checks, it was transported to the Satish Dhawan Space Centre in Sriharikota, India, for final launch preparations. This partnership brought teams together from around the world, including JPL systems engineer Akshata Krishnamurthy. She grew up in Bengaluru and has been traveling from California back home to India to support the mission. Let's take a look at part of her journey.
Hey everyone, I am at LAX right now. I just finished security and I'm ready to board. It's the first of 3 flights with stopover in Dallas, Soha, and Bangalore. I have arrived in Bangalore Airport, or as we call it, Bengaluru, after about 31 hours of flying. I'm excited, but I'm also super tired, so I'm going to go get my bags and head to the hotel, and I'll see you later. I grew up in Bangalore. It is amazing and nostalgic, in fact, to come here because it was my dream job to work at NASA. Now I'm able to contribute to my home country on a project where we're doing an international collaboration. So super excited to be a part of this effort and also grateful for this experience. So finally, I'm here at the URL Satellite Center, URSC, here in Bangalore. This is the ISRO Center where we're going to be working the next few days. We're gearing up for our next set of system level testing. Today we're going to have a day full of intense technical discussions with the NISAR team here at ISRO right behind me. I'm walking in to Rajasthani. It's a traditional Rajasthani cuisine restaurant. You will get to see one of India's cuisines. It has 28 states, and each state has its own cuisine. And here we explore different types of cuisines with our ISRO colleagues and friends.
We're
waiting for the traditional lamp lighting ceremony, what we call the diyas. And the background music that plays is really a world peace and happiness prayer. It was so soothing and it was such a positive energy here. I wish you could all witness this. Thank you for joining me on this tour of my city. I hope you enjoyed it as much as I did. I can't wait to see the launch and operate this amazing observatory.
Sue, you also traveled to India for this mission.
Yes, I did. It was really an amazing experience. It was my first trip to India. I went in February of 2020 to meet with the science team in India, and again a few years later.
And, you know, speaking of travel, NASA leadership is on the ground right now in India getting ready for launch. Here's what they had to say.
I'm here in India, super excited as we are here to support our NISAR mission as it takes to the skies. And today, it's all about NISAR.
It's an exciting week for NASA. We have our Crew 11 launch in Florida, and we have our NISAR launch here in India, which is where I am with our NASA team. Super excited to be here, an incredible collaboration between India, the United States. This launch really represents the culmination of over 10 years of collaborations between our two countries. So go NASA, go JPL, go ISRO, go NISAR.
I'm here today at IIT Madras for the pre-launch science team meeting for the NISAR mission. We are learning all about the terrific science that's going to come out of this mission. I just heard about how NISAR will revolutionize our understanding of how earthquakes happen around the globe. The excitement for launch here is palpable, and I can't wait to get back inside and hear more.
Go NISAR indeed, and to help us better understand the spacecraft, you have brought a model with us.
Yes, so here we have a model of the NISAR spacecraft. You can see here we have solar panels to power the spacecraft. Here we have in this octagonal structure, this is the radar instrument structure, or the RIS. So the L and the S-band radar are housed here. And then behind that is the spacecraft bus, which houses the power and the telemetry and other key functions of the satellite. Then attached to that is this impressive boom that holds up the nearly 40-foot in diameter gold reflector antenna reflector of NISAR.
And so it is not going to launch in this configuration, right? It has to be packed up. So how does that work?
So right now it's all folded up and stored and ready for launch. And so the way that it folds up is this boom actually wraps around the radar instrument structure. But first, the antenna reflector folds up. So it kind of collapses like an umbrella or a camp chair. And then it's stored underneath the radar instrument structure in this configuration. And it's held in place by this little latch down here.
Well, that is exciting stuff. Thank you so much for the breakdown, Sue. So NISAR is a joint mission between NASA and ISRO, but that is just one example of how our two countries are working together in space. So here's more in your Artemis Moon Minute. QR code you see on your screen. And as you do that, it's also worth mentioning another NASA and ISRO partnership. Last month, ISRO made history with its first astronaut visiting the International Space Station as part of the NASA and Axiom Space's AX-4 mission. Shifting gears back to NISAR, the Earth Observing Satellite is set to give scientists a clearer view of how ice is moving, melting, and reshaping our world. Here to tell us more is Eric Rignot. Thanks for being here today.
You're welcome.
So how can NISAR help us understand how tracking melting ice from glaciers and ice sheets is important?
NISAR will track the motion of glaciers and ice sheets and combine with information from climate models and thickness of the ice, we can figure out how much they contribute to sea level rise. And glacier melt is one of the main contributions to sea level rise. We have We need this information to inform society on how to protect ourselves from sea level rise. And then the scientists will be able to use this information in climate models to project what sea level would look like in the next few years, in the next decades, in the next century, so we can better protect society and save human lives too.
Very important information.
So Eric, can you tell us how will NISAR help us see changes in the ice that are difficult to detect from the ground?
Yeah, so the NISAR will cover the globe in 12 days, and in particular it will cover all of Antarctica for the first time. And conducting these measurements in the Antarctic would be nearly impossible for ground parties because the continent is so vast. It's larger than the United States, and it would put these field teams in great danger if they had to do this work continuously on the Antarctic. So with NISAR, we'll have this information continuously about what's happening in the Antarctic. If there's any important event, we'll see it, we'll catch it, and it will be part of public knowledge from this data.
Thank you, Eric. That's great.
Eric, that was really important information. Thank you so much for joining us today. And let's take another look into mission control here at JPL, where the team is excited to watch launch. And just a few days ago, I had a chance to speak with Dave Gallagher, the new director of JPL, to hear his thoughts on launch. Dave, thank you so much for joining us today.
It's my pleasure, Raquel. I'm happy to be here.
From your perspective, why is NISAR such a groundbreaking collaboration between NASA and ISRO?
This is the single biggest collaboration in space between the United States and India. It's enormously important to both countries, and space diplomacy is key right now. One of the most challenging things about this collaboration is the difficult time zone. So we have our JPL engineers and scientists working shoulder to shoulder with their ISRO counterparts, and the team is just working fantastic together.
When people think of JPL, they probably think of Mars rovers or deep space exploration, but JPL is also dedicated to studying Earth science and our home planet. What do you hope NISAR will achieve that adds on to those many Earth missions?
Well, Raquel, just to build on what you said, we actually have 4 decades of pioneering missions to really understand our home planet, missions like GRACE, missions like EMIT, like SWAT, that are born here and really have turned out to be some of the most important missions in existence to understand our home planet. NISAR is going to give us an unprecedented view of the Earth, both our ice mass, land mass, and because it's synthetic aperture radar, which is a technology really pioneered at JPL, it can work day and night and through any kind of weather.
Can you tell us how the JPL team contributed to NISAR and what that says about JPL's history of working on international partnerships?
Absolutely. This will be the first mission to use 2 kinds of radar. The L-band radar is developed by JPL. The S-band radar is developed by ISRO. And that combination of those 2 radar systems will allow us an unprecedented understanding and view of the Earth. NISAR builds on JPL's long-standing legacy of working with international partners. We can drive innovation when we take advantage of each country's strengths. We are actually stronger when we work together than doing this alone.
So looking ahead, what kind of legacy do you hope NISAR leaves behind for future Earth science missions?
What I'm most excited about with NISAR is the real-world applications, things like infrastructure monitoring, natural disaster recovery and response, agriculture management. This is going to make a real difference for real people around the world.
Thank you so much for your time and insights today.
Thanks.
As a reminder, this is a joint broadcast, and we will hand it over to ISRO, who will cover NISAR's launch, which is just about 36 minutes away. And Sue, we have another social media question coming in. So Pradeep on X wants to know, how will NISAR's satellite be different from others, and what capabilities does it have which others don't?
That's a great question. So a key difference from NISAR is that it is going to be globally measuring at very high spatial resolution. So this is the technology or the capability enabled by the radar technology that is called SweepSAR, as well as the very large antenna reflector that we saw earlier. Another key innovation from NISAR is the dual band radar. It will be the first satellite to be measuring with both L and S band.
Well, thank you so much for those questions. And if you have a question, send them over using the hashtag AskNISAR. And as we showed you about 15 minutes ago, NASA leadership is on the ground right now in India. That includes Associate Administrator for Science, Nikki Fox. I was able to catch up with her before she left to talk about this historic partnership.
Nikki, thank you so much for joining us today.
Oh, you're so welcome. It's a great day.
NASA has more than 24 missions focused on Earth science right now. What makes NISAR unique?
We really don't quite understand why our planet is always moving. The surface of the planet is always kind of moving, and we can't detect it. But with this amazing technology that NISAR brings, we're going to be able to actually start studying these tiny little, almost landslides, these little tiny quakes. And the goal, of course, being that we find a signature that happens before a major disaster that would allow us to then look for that and search for it and almost be able to predict these big disasters before they happen.
And you mentioned those tiny changes that this mission will track. What kind of other insights may we gain that could help people in their everyday lives?
We're also getting the data into the hands of people that need it, the decision makers, the people who are working with the first responders to actually go in and help people once these disasters have happened. You mentioned how many missions we have in the Earth Science Fleet. And when you put all these missions together, you just get so much more out of them. And so having NISAR launch take its place in the Earth Science Fleet, really illuminating so much more about our home planet, NISAR is just going to give us unprecedented views to add to the information we have about our planet.
And Nikki, we are so close to launch. So what are you looking most forward to right now?
Oh my goodness. I love a good launch. I'm not going to lie. I'm a launch junkie. I love everything about them. But really it's that final sort of when you get to that final countdown and, you just appreciate, for me, being with the team, being with this combined team who've worked so hard to make this happen. I know I've been on mission teams and it's almost like you're sprinting to the start line as a scientist. You've done all the work, the mission is there, it's on the rocket. Once it launches, all of the science begins.
Fantastic. Thank you so much for joining us today.
Thank you so much. Go NISAR.
And Sue, we have more social questions coming in, so why don't you answer some more? We have Ayush on YouTube who wants to know, how long will it take to get NISAR fully running?
So that's a good question. So it will take about 90 days before we start collecting, before the science mission starts and we start collecting science data. So in those 90 days, we will be deploying the satellite, deploying the boom and the reflector, as well as testing out all of the radar instruments and making sure that everything is calibrated and validated initially correctly.
So 90 days from now will be like Christmas for you.
Yes, it will.
And Rian on YouTube wants to know, how will ISRO and NASA ensure NISAR's data is accessible and useful for developing nations most affected by climate change?
Oh, that is a wonderful question. So NASA has an open science policy and open data policy. And so all of the data that NISAR will be collecting, all of the L-band data will be available through a NASA archive at the Alaska Satellite Facility, and then India will also be making their data available, the S-band data and L-band data that they will be processing, available and openly free and available to everyone through their data archive as well. So all of the data will be free.
Great, and we have a couple more coming in. Raul on X wants to know, why is NISAR's antenna so big compared to other Earth-observing satellites, and what is it made out of?
So I can answer the first question. I don't think I have the exact facts for the second question about what it's made of. But the reason why it needs to be so large is that area gives us the very high spatial resolution that is going to be unique to NISAR, combining that global coverage as well as the high spatial resolution. So we need that surface area to collect all the reflected radar signal from the Earth, focus it onto the receiving antenna, and that will give us the high spatial resolution.
Thank you, Sue. So Anjin 018 on YouTube wants to know, since NISAR uses both L-band and S-band SAR, how does the dual-band radar improve surface imagery accuracy, especially in densely vegetated and urban regions? These are some great questions.
Yeah. So how will the L and S-band radar help us improve the, what was it, the surface deformation?
Vegetated and urban regions.
Vegetated and urban regions. So that because the two different radars are different wavelengths, they will be sensitive to different parts of the vegetated environment, and so we'll be able to characterize the vegetated areas more accurately using the two different wavelengths.
From Satish Dhawan Space Centre, Sue. Thank you so much, and thank you all for your questions.
We extend a hearty welcome to the viewers.
Just 30
this
minutes
telecast
away, so
is being brought to you from the Mission Control Center.
And the NISAR team.
I am Madhuri giving the commentary in English, and with me is my co-commentator Sri Vikas Swarnkar, who will be giving the commentary in Hindi. Today, the GSLV F-16 mission will carry NISAR, or the NASA-ISRO Synthetic Aperture Radar satellite, into polar orbit. The launch is scheduled today, the 30th of July 2025, at 17:40 hours IST, or 12:10 hours Coordinated Universal Time from the second launch pad. This mission intends to place the NISAR satellite weighing about 2,400 kilograms in 747.4 kilometers circular polar sun-synchronous orbit with an inclination of 98.4 degrees.
नमस्कार, शुभ संध्या। स्वागत है आप सभी दर्शकों का। आज एक ऐतिहासिक दिन है जब अंतरिक्ष अनुप्रयोगों में विश्व के दो अनुभवी एजेंसियां नासा और इसरो द्वारा सहभागिता से तैयार यह उपग्रह, जिसे हम निसार नासा इसरो सिंथेटिक अपर्चर रडार के नाम से जानते हैं, इस उपग्रह का प्रमोशन के साथ एक स्वर्णिम अध्याय लिखा जाएगा जो कि अंतर्राष्ट्रीय सहयोग का अद्वितीय उदाहरण होगा। तो हमारे साथ बने रहिए इस अभूतपूर्व घटना के। मैं विकास स्वर्णकार आप सभी का हार्दिक स्वागत करता हूं। मैं आप सबके सामने इस प्रमोशन मिशन का हिंदी में प्रस्तुतिकरण करूंगा और मेरे साथ हैं सुश्री माधुरी पी, जो इंग्लिश में कमेंट्री प्रस्तुत करेंगी। हम आप सभी दर्शकों का इसरो के श्रीहरिकोटा के मिशन नियंत्रण केंद्र से हार्दिक स्वागत और अभिनंदन करते हैं। GSLV F-16 निसार मिशन के तहत आज 30 जुलाई 2025 को भारतीय मानक समयानुसार शाम 5:40 और 25 सेकंड पर श्रीहरिकोटा के द्वितीय प्रमोशन मंच से GSLV F-16 का प्रमोशन किया जाएगा। इस प्रमोशन मिशन का उद्देश्य है लगभग 2400 किलोग्राम वाले भूप्रेक्षण उपग्रह नाइसार को 747 किलोमीटर की गोलाकार कक्षा में स्थापित करना। इस प्रमोशन मिशन को पूरा करने के लिए GSLV Mark II प्रमोशन यान का उपयोग किया जा रहा है। GSLV Mark II त्रिचरणीय प्रमोचक यान है और इससे पहले यह 17 उड़ानें भर चुका है और वर्तमान में यह 18वीं उड़ान भरने जा रहा है। इस साल ही हमने 29 जनवरी 2025 को GSLV F-15 द्वारा NVS-2 उपग्रह का सफलतापूर्वक प्रक्षेपण देखा और आज हम पूर्णतः तैयार हैं, सज्ज हैं अपने अगले मिशन, जिसका नाम है GSLV F-16 NISAR मिशन।
NISAR is the world's most sophisticated Earth observation satellite, jointly developed by ISRO and NASA. Its 12-meter deployable mesh antenna is one of the largest in Earth observation history and uses a unique operating mode called Sweep SAR to observe Earth with a swath of 242 kilometers and a high spatial resolution. NISAR will carry L-band and S-band radars, which are designed to work independently or together. While the L-band radar contributed by NASA will work with longer wavelengths of about 25 centimeters to penetrate vegetation, soil, ice, enabling detailed tracking of soil moisture, forest biomass, ice sheet thickness, and subsurface features. The S-band radar contributed by ISRO will operate on shorter wavelength of 12 centimeters, which makes it highly sensitive to surface characteristics. It is useful for detecting crop structures, snow cover, and fine surface deformation.
नाइसार नासा इसरो सिंथेटिक अपर्चर रडार नासा और इसरो द्वारा संयुक्त रूप से विकसित की गई एक निम्न भू कक्षा की वेधशाला है। इसकी खास बात यह है कि नाइसार 12 दिनों में पूरे पृथ्वी का मानचित्र तैयार कर पाएगा और पृथ्वी के पारिस्थितिक तंत्र, बर्फ का द्रव्यमान, वनस्पति बायोमास, समुद्र के स्तर की में वृद्धि, भूजल, भूकंप, सुनामी, ज्वालामुखी और भूस्खलन सहित प्राकृतिक खतरों को समझने में बेहतर डेटा प्रदान करेगा। अब आप सभी दर्शकों के सामने GSLV F-16 लॉन्च व्हीकल का इंटीग्रेशन वीडियो प्रस्तुत है।
We bring to you the integration video of GSLV F-16 mission here at Satish Dhawan Space Centre, Sriharikota. The launch campaign begins with the flag off of the nozzle end segment from its preparation building to the vehicle assembly building, where it is being handled and carefully positioned on the mobile launch pedestal. The first stage of GSLV consists of 5 solid motor segments, which have a case-bonded HTPB-based solid propellant. It has a nozzle end segment, 3 middle segments, and 1 head end segment. On your screens now is the handling of head end segment. That is the igniter being integrated on the top of the first stage motor, the interstage 1-2. It is a vented interstage to enable hot separation of GS1. The strap-on motors called the L40s being prepared in a separate building, handled and moved to the vehicle assembly building to be tilted and then assembled with the core motor. There are 4 L40 strap-ons in GSLV. You can see on your screens it has completely been assembled.
अभी अभी आपने प्रथम चरण का संयोजन देखा जिसमें हम ठोस नोदक का प्रयोग करते हैं और अभी आप देख रहे हैं यह द्वितीय चरण है GSLV Mark II का, जिसे हम GS2HT कहते हैं। यह अभी तरल नोदक वाला चरण है और इसमें आप देख सकते हैं यह विकास इंजन है। इसमें भारत पूरी तरह स्वायत्त प्राप्त कर चुका है। इसके पूर्ण परीक्षण के पश्चात इसे IPRC महेंद्रगिरी द्वारा सतीश धवन अंतरिक्ष केंद्र लाया जाता है। आगे के परीक्षण के पश्चात इसे यान में समायोजित कर दिया जाता है। यह क्रायो स्टेज है, तृतीय चरण है GSLV Mark II का। यह तृतीय और अंतिम चरण है जो क्रायो ईंधन का प्रयोग करता है, लिक्विड ऑक्सीजन तथा लिक्विड हाइड्रोजन का ईंधन के रूप में इस्तेमाल करता है। यह अंतिम चरण है और इसके ऊपर में उपग्रह को समायोजित किया जाएगा और यह है हमारा उपग्रह NISAR.
On your screens now is the spacecraft NISAR. In the visuals before this, you have watched the integration of the second stage being operated on Earth storable propellant and then the cryo stage, and these are the visuals from the spacecraft preparation facility, the clean room where the encapsulation of the spacecraft is taking place.
पूर्ण परीक्षण के पश्चात उपग्रह को एनकैप्सुलेट कर दिया गया है ऊष्मा कवच के अंदर तथा इसे VAB वेहिकल असेंबली बिल्डिंग लाया जा रहा है। इसके पश्चात इसे पूरी सावधानी, गुणवत्ता, सुरक्षा के साथ यान के साथ समायोजित कर दिया जाएगा। और इस तरह पूरी तरह तैयार सुसज्ज अपने मिशन को पूरा करने GSLV F-16 प्रमोचक यान VAB से UT की तरफ लाया जा रहा है, umbilical टावर की तरफ.
That's the movement of the fully integrated GSLV F-16 to the umbilical tower of the second launch pad.
आगे की गतिविधियां तथा परीक्षण यहां umbilical टावर से किए जाते हैं. यहां तरल नोदक का भराव तथा स्वास्थ्य जांच यहां से पूरी की जाएंगी.
We are about 20 minutes away from the launch. The countdown for this mission was 27.5 hours long, and it had started yesterday, that is the 29th of July at 14:10 hours here.
GSLV F-16 प्रमोचन की उल्टी गिनती 27.5 घंटे पूर्व प्रारंभ हो चुकी है. अभी अभी आप सभी दर्शकों ने सुना, रेंज ऑपरेशन डायरेक्टर ने अपने तंत्र की सूचना मिशन डायरेक्टर को दे दी है.
मिशन डायरेक्टर रोजर.
उड़ान की उल्टी गिनती जारी है और उसी के अनुसार सारी गतिविधियां अबाध रूप से जारी हैं. कुछ अंतिम जांच के पश्चात स्वचालित प्रक्षेपण अनुक्रम यानी ऑटोमेटिक लॉन्च सीक्वेंस शुरू किया जाएगा. इस दौरान यान निदेशक, रेंज ऑपरेशन डायरेक्टर, टेलीमेट्री ट्रैकिंग कमांड
मिशन डायरेक्टर रोजर
और सैटेलाइट डायरेक्टर अपने अपने तंत्रों की सूचना मिशन डायरेक्टर को देंगे.
During the countdown, the servicing operations for the Earth storable propellants into the GS2 stage and the 4 numbers of L40 strap-ons was carried out. Health checks were carried out on the spacecraft and the launch vehicle. The meteorology instruments at the spaceport will indicate crucial data to comply to the launch commit criteria. Radars carry out transmission checks and cryopropellants are serviced few hours ahead of launch.
Mission Readiness Review Committee and the Launch Authorization Board have granted clearance to proceed with the countdown and launch of GSLV F-16 NISR mission. All operations up to the initiation of automatic launch sequence have been completed satisfactorily. Based on the clearances received for the launch vehicle, spacecraft, range systems, ISRO ground stations, and considering the favorable weather conditions, Mission Director hereby authorized the commencement of launch operation sequence for the GSLV F-16 NISR mission at 17 hours 40 minutes and 25 seconds IST. Today, the 30th July 2025.
This is Vehicle Director. Pre-launch operations of cryo stage is authorized.
To note, Mission Director has given authorization for the launch of GSLV F-16 NISR mission.
अभी आप सभी दर्शकों ने सुना, सभी तंत्र सामान्य रूप से कार्य करते हुए और उनके तंत्रों की जानकारी मिशन निदेशक तक पहुंच चुकी है. तत्पश्चात मिशन निदेशक ने ऑटोमेटिक लॉन्च सीक्वेंस शुरू करने का अनुमोदन प्रदान कर दिया है और ऑटोमेटिक लॉन्च सीक्वेंस शुरू हो चुका है.
Automatic launch sequence has been authorized by the mission director. In the preceding 14 minutes before launch, a capsule of crucial functional aspects of launch vehicle systems, which includes actuation of liquid stage engine actuators, health confirmation of ground systems that are crucial for the launch, and very close to T0, control is passed on to the onboard computers.
अब हम उड़ान से 17 मिनट की दूरी पर हैं.
T-17 minutes.
उल्टी गिनती प्रारंभ होने के पश्चात यान को पावर ऑन किया गया. GS2 यानी द्वितीय चरण जो है तरल नोदक का भराव सुनिश्चित कर लिया गया उसमें. उसके बाद L40 चरणों में जो कि तरल नोदक पर आधारित चरण है उसमें भी तरल नोदक का भराव सुनिश्चित किया गया. मिशन कंप्यूटर और रडार उपकरणों की स्वास्थ्य जांच की गई. क्रायो आर्म तथा क्रायो अपर स्टेज में फिलिंग के लिए तैयार कर उसमें ईंधन का भराव सुनिश्चित कर लिया गया है। अंतरिक्ष यान को पावर ऑन कर सभी स्वास्थ्य जांच पूरी की जा चुकी है। एयर ट्रैफिक कंट्रोलर तथा जल परिवहन विभाग से भी अनुमति प्राप्त की जा चुकी है। हमारे मौसम विभाग से भी पूर्व सूचना प्राप्त की गई है और इस दौरान मौसम पूरी तरह प्रमोशन के लिए अनुकूल बताया गया है। ऑटोमेटिक लॉन्च सीक्वेंस जारी है। इस दौरान स्वतः ऑन
T-16 minutes.
ऑटोमेटिक
Based on
लॉन्च
mission director
सीक्वेंस
authorization,
कंप्यूटर
vehicle
द्वारा
director hereby
सभी
authorizes
जांच पूरी
to
की जाएंगी।
initiate automatic launch sequence for the launch of GSLV F-16 NISR mission.
SDS servers activated. MC confirms data from SHAR-1 and SHAR-2.
GSLV F-16 mission at the second launch pad. It's getting ready for its first ever mission to sun synchronous polar orbit.
Automatic launch sequence initiated for GSLV F-16 and NISAR mission.
ALS in auto mode.
Operations commenced.
नाइसार उपग्रह एल और एस बैंड वाले दोहरे बैंड संश्लेषी अपर्चर रडार वाला उपग्रह है जो उच्च विभेदन के साथ बड़े प्रमाण को प्राप्त करने के लिए सीट SAR तकनीक से संचालित होगा। नासा के जेट प्रणोदन प्रयोगशाला, जेट प्रोपल्शन लैबोरेटरी और इसरो के सहयोग से तैयार नाइसार जो न केवल संबंधित राष्ट्रीय जरूरतों को पूरा करेगा बल्कि पूरे विश्व के विज्ञान समुदाय की भी डेटा आपूर्ति करेगा। नाइसार के बारे में प्रचलित कथन इस प्रकार है: दो संस्कृतियों का सही सम्मिश्रण और वैज्ञानिक शिल्पकारों की एक उत्कृष्ट रचना का नाम नाइसार है।
.7 meter tall GSLV is a 3-stage launch vehicle of 420.5 tons liftoff mass. The first stage, GS1, comprises of S-139 solid booster and 4 strap-ons of liquid L-40. The second stage, GS2, is Earth storable liquid stage of GL-40 HT.
L-40 EGC actuation in
The third
progress.
stage, GS3, otherwise called CUS-15, and is powered by cryogenic propellant combination of LOX and liquid hydrogen. The payload fairing is of ogive shape with 4 meter diameter.
यह रचना आपके सामने प्रस्तुत है GSLV F-16 प्रमोचक यान की। कुल ऊंचाई 51.7 मीटर। इसका कुल उत्थापन भार 420.5 टन का होता है। त्रिचरणीय है यान है यह। प्रथम चरण में S-139 तथा चार L-40 स्ट्रैप-ऑन्स लगे हुए हैं। द्वितीय चरण में L-40 तथा तृतीय में क्रायो अपर स्टेज जो कि क्रायो इंजन वाला चरण है। और ऊपर में हमारा उपग्रह नाइसार पूरी तरह सुरक्षित है। पेलोड फेयरिंग के अंतर्गत इस समय पेलोड फेयरिंग 4 मीटर व्यास वाली ओजिव पेलोड फेयरिंग का इस्तेमाल किया जा रहा है।
EGC actuation completed.
सभी गणमान्य व्यक्ति यहाँ उपस्थित लॉन्च का अनुभव लेने यहाँ उपस्थित हुए हैं। GSLV F-16 की उड़ान दक्षिणी दिशा की उड़ान होने जा रही है, इसलिए इस प्रमोचक यान को पूर्णतः ट्रैकिंग रेंज में रखने के लिए 4 भू-स्थित रडार ट्रैकिंग स्टेशंस जो कि शार, त्रिवेंद्रम, मॉरिशस और अंटार्कटिका में स्थित हैं, यह यान पर पूरी तरह निगरानी रखेंगे और हम तक सभी आंकड़े वास्तविक समय पर उपलब्ध करेंगे।
We are 11 minutes 45 seconds from the launch. In the preceding several months, both ISRO and NASA have disseminated information about the mission and data characteristics to enable prospective users to take full advantage of the data gathered by NISAR when it becomes available.
सभी वैज्ञानिक अपने कंसोल पर आंकड़ों का अध्ययन करते हुए सभी तंत्र अभी तक सामान्य कार्य पर हैं और यह आपके सामने है लॉन्च व्यू गैलरी का दृश्य। आप देख सकते हैं बहुत ही उत्साह सभी छात्र छात्राओं पर भारी संख्या पे यहाँ भीड़ उमड़ आई है इस प्रमोचक यान का अनुभव लेने के लिए। ये शब्दों से बाहर का अनुभव होता है, अपनी आंखों से स्वानुभव लेने वाला यह पल। देखिए क्या उत्साह
of the students here at the launch view gallery at Sriharikota.
उत्साह देखते ही बनता है छात्रों का। बहुत समय के इंतजार के पश्चात उन्हें यह पल मिला है जब वह एक बार फिर यह प्रमोशन देख सकते हैं।
T-10 minutes.
GS2 radar engine actuation in progress.
ISRO is bringing to you a curtain raiser for the mission NISAR for your better understanding about the mission.
In an era where climate change dominates global discourse, humanity faces an increasing vulnerability to natural disasters. To address these mounting challenges, NASA and ISRO have joined forces in an extraordinary collaboration to launch the NASA-ISRO Synthetic Aperture Radar Satellite, NISAR. This groundbreaking low Earth orbit LEO observatory promises to revolutionize the way we understand our dynamic planet. Equipped with state-of-the-art LNS-band synthetic aperture radar, SAR systems, NISAR will use the sweep SAR technique to deliver high-resolution images across vast swaths of the Earth's surface. Incredibly, it will map the entire globe every 12 days, offering unprecedented consistency in spatial and temporal data. NISAR's mission is nothing short of transformative. From tracking glacial melt and monitoring agricultural landscapes to analyzing seismic shifts and managing disaster response, it will empower scientists, researchers, and policymakers with vital insights. By precisely measuring minuscule movements and colossal environmental events alike, NISAR will help us decode Earth's complex ecosystems and natural hazards. The flagship mission sees NASA contributing the L-band SAR, engineering payloads, critical systems like GPS receivers, and the solid-state recorder. ISRO is supplying the S-band SAR, spacecraft bus, and will launch the satellite aboard through its vehicle GSLV F-16 from Sriharikota. A majestic 12-meter unfurlable reflector antenna will unite the dual-band systems, enabling powerful Earth observations from orbit. The geosynchronous satellite launch vehicle GSLV F-16 features a three-stage configuration. Its first stage comprises a solid rocket motor at the core, supported by 4 liquid strap-on boosters. The second stage operates on liquid propellant, while the third and final stage is powered by an indigenously developed cryogenic upper stage. The payload fairing for the GSLV F-16 NISAR mission features a 4-meter diameter OGIV configuration. The launch will take place from the second launch pad at India's spaceport SDSC Shar at Sriharikota. It is the first GSLV mission to be launched into a sun-synchronous polar orbit. NISAR is not just a satellite, it's a symbol of global unity, scientific excellence, and hope. It promises to safeguard our future by helping humanity live more wisely with nature.
T-6 minutes.
ऑटोमेटिक लॉन्च सीक्वेंस जारी है और अब हम 6 मिनट दूर हैं उड़ान से। इस दौरान आपको इस प्रमोशन का विवरण देते हैं। GSLV Mark 2 3 चरणों से बना हुआ प्रज्ञान है। प्रथम चरण में ठोस नोदक वाला S139 कोर स्टेज बूस्टर है जो कि PSLV से व्युत्पन्न चरण है, लेकिन इसमें प्रथम चरण के साथ 4 L40 तरल नोदक वाले स्ट्रपॉन बूस्टर संलग्न रहते हैं। L40 स्ट्रपॉन विकास इंजन द्वारा संचालित किए जाते हैं। कोर S139 मोटर के साथ मिलकर कुल 8000 किलो न्यूटन का प्रणोद उत्पन्न करते हैं। यह प्रणोद आवश्यक होता है यान के उत्थापन के लिए। प्रथम चरण लगभग 112 सेकंड प्रज्वलित रहकर यान को 54 किलोमीटर की ऊंचाई प्रदान करेगा तथा इस समय 24 किलोमीटर प्रति सेकंड की सापेक्ष गति होगी। L40 स्ट्रपॉन 150 सेकंड तक प्रज्वलित रहता है। इसके बाद लगभग 600 मिलीसेकंड बाद द्वितीय चरण प्रज्वलित होता है और इसके तुरंत बाद प्रथम चरण के यान से पृथक कर दिया जाता है। द्वितीय चरण फिर से तरल नोदक वाला चरण है। द्वितीय चरण विश्वसनीय विकास इंजन के साथ 846 किलो न्यूटन का प्रणोद उत्पन्न करता है। यह लगभग 146 सेकंड तक प्रज्वलित रहकर यान को 338 किलोमीटर की ऊंचाई तथा 3.5 किलोमीटर प्रति सेकंड की सापेक्ष गति पर ले आएगा। द्वितीय चरण के दौरान यान से ऊष्मा कवच यानी पेलोड फेयरिंग को अलग कर दिया जाता है और यान क्लोज लूप गाइडेंस के अंतर्गत अपना दिशा निर्धारण करता है। द्वितीय चरण की समाप्ति के पूर्व ही तृतीय चरण जो कि क्रायोजेनिक ईंधन वाला चरण है उसे प्राधिकृत किया जाता है।
T-4 minutes.
द्वितीय चरण के पृथक्करण के तुरंत बाद GSLV का तीसरा और सबसे जटिल क्रायो इंजन प्रज्वलित होता है। क्रायो चरण के पूर्ण प्रज्वलन की पुष्टि हो जाने पर उसमें 11% अतिरिक्त प्रणोद के लिए कमांड दिया जाएगा। इसमें CE 7.5 इंजन का क्रायोजेनिक इंजन का उपयोग किया जा रहा है जो कि 75 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह संवर्धित प्रणोद के साथ यान लगभग 400 सेकंड में 780 किलोमीटर की ऊंचाई प्राप्त कर चुका होगा और सापेक्ष गति 4.57 किलोमीटर प्रति सेकंड। इसके पश्चात क्रायो चरण को पुनः सामान्य प्रणोद के लिए कार्यशील किया जाएगा और फिर 400 सेकंड पर वह 7.5 किलोमीटर प्रति सेकंड की सापेक्ष गति प्राप्त करेगा और अंतरिक्ष यान को अंतःक्षेपण की स्थितियां प्राप्त करेगा। यह पूरा कार्य लगभग 1115 सेकंड पर पूरा किया जाएगा।
We are about 2 minutes and 50 seconds from the launch. Let us take a quick look at the mission events for GSLV F-16 NISAR mission. The L-40 strap-ons ignite 4.8 seconds ahead of T0 so that their nominal thrust can be ascertained before igniting the booster. Liftoff coincides with the ignition of S-139, also called as GS-1 at T0. The burn time of GS-1 is 112 seconds and that of the L-40s is 149 seconds. By the time GS-1 and L-40s finish their operation, the launch vehicle is at 104 kilometers altitude. In a staging event typically called as hot separation, the GS-2 stage is ignited 600 milliseconds after the L-40 thrust cutoff and 1.6 seconds later, the stage separation takes place. When the launch vehicle reaches 138 kilometers altitude, the dense atmosphere would have cleared. Since the need for thermal shielding and aerodynamic shape is no longer significant, the payload fairing is jettisoned. Closed loop guidance also is initiated. At this point of time in the mission, the launch vehicle would have acquired 2.1 kilometers per second relative velocity. For the present mission, the burn time for GS2 is 140 seconds. It is separated 4 minutes 53 seconds into the flight. The third stage is the cryogenic upper stage, which plays a significant role in the mission. Its high specific impulse together with a long burn time of more than 13 minutes, it adds tremendous relative velocity to the launch vehicle. The CUS operation adds 376.55 kilometers
stand
in
by
altitude
for the time mark.
and
T
increases
minus 1
relative
minute.
velocity from 3.5 kilometers per second to 7.5 kilometers per second. An operational philosophy unique to the
Minus 50
GSLV
seconds.
F-16 NISAR mission
Sequences
is
are up.
that CUS stage is operated by 11%
Minus
for the
45
duration
seconds.
of 405 seconds. About 11 minutes into flight,
Minus
the
40
cryogenic
seconds.
upper stage shuts down. The satellite NISAR is separated to
35
be
seconds.
injected into an altitude of 745.5
Minus 30
kilometers
seconds.
with a relative velocity of 7.57 kilometers per second.
Minus 25 seconds.
We are mere 25 seconds from the launch.
All our movies open. Minus 20 seconds.
सभी दर्शक हमारे साथ बने रहिए।
Minus 15
सर्वप्रथम
seconds.
T- 4.8 सेकंड्स पर L40s का प्रज्वलन हम देखेंगे।
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All L40 engines generating nominal thrust. S139 motor
Plus 5
ignited.
seconds.
That's a
Speed
magnificent
tracking.
of the GSLV F-16
Liftoff normal.
NISAR mission. The deafening roar of GSLV and beautiful
15 seconds.
silhouette brightening the Sriharikota sky.
जी हाँ, अभी आपने देखा चारों L40 तथा कोर बूस्टर S139 का सफल प्रज्वलन
25 seconds.
और GSLV F-16 का उत्थापन द्वितीय प्रमोचन मंच से, और ये अपने गंतव्य की ओर बढ़ता हुआ। हम यहाँ कंपन महसूस कर पा रहे हैं मिशन नियंत्रण केंद्र पर।
The first stage of GSLV with S139 solid core motor and 4 L40 liquid strap-ons thrusting together. 7,800 kilonewton cumulative thrust.
First stage performance normal.
Sharwan is in main auto.
The day of launch
Plus
wind
1
biasing
minute.
program that is fed into the onboard computers helped the rocket to
Shah
veer
2 is
through
in
the
main auto.
atmosphere with minimal aerodynamic loads.
प्रथम चरण का कोर बूस्टर लगभग 100 सेकेंड्स तक प्रज्वलित रहेगा तथा L40 चरण 150 सेकेंड तक प्रज्वलित रहकर शांत हो जाएंगे। तत्पश्चात इसे यान से पृथक कर दिया जाएगा। वर्तमान में सभी तंत्र सामान्य निष्पादन करते हुए और यान अपने अपेक्षित पथ का अनुकरण करता हुआ
First
जा
stage
रहा है।
performance normal.
Currently the rocket is in open loop guidance. Shar ground station is tracking.
S139 burnout.
कोर बूस्टर का प्रज्वलन समाप्त हो चुका है।
Here
Plus
we have
2
an
minutes.
announcement from the range operations director that the booster has stopped its operation. The 4 L40s are thrusting still.
First stage performance normal.
प्रथम चरण का कार्य निष्पादन पूरी तरह सामान्य। यान उद्दिष्ट दिशा की ओर अग्रसर होता हुआ वर्तमान में प्रथम चरण प्रज्वलित है। L40s प्रज्वलित हैं। इनका कुल कार्यकाल 150 सेकंड का होगा।
L40 shut off. GS2 ignited. GS1 separated. 1S. IS 1/2 main separated.
जी हाँ, अभी आपने सुना रेंज ऑपरेशन निदेशक ने इसकी पुष्टि की है। प्रथम चरण को सफलता से पृथक किया जा चुका है
Payload
तथा
fairing separated.
द्वितीय चरण का प्रज्वलन शुरू हो चुका है।
Marking
Closed loop
the
guidance
milestone in
initiated.
the flight, the GS1 has undergone a hot separation and GS2 commenced its operation and thrusting nominally. The payload fairing has also been separated and closed loop guidance has been initiated.
जी हाँ, इस दौरान
Second stage performance normal.
वातावरण से बाहर जा चुका है, इसलिए पेलोड फेयरिंग या ऊष्मा कवच की आवश्यकता नहीं रहती, इसलिए इसे यान से पृथक कर दिया जाता है। और अब यान क्लोज लूप गाइडेंस के अंतर्गत है और स्वतः ही अपना दिशा निर्धारण कर रहा है।
Powered by the Vikas engine that uses the Earth storable propellant combination of UH-25 and N2O4, the second stage of GSLV develops 846 kilonewton thrust in vacuum. Burn time for this mission of GS2 is 140 seconds.
+4 minutes.
दर्शकों का उत्साह देखते ही बनता है यहाँ पर, सभी
Second
उत्साहित
stage
इस प्रमोशन
performance
को लेकर।
normal.
द्वितीय चरण सामान्य निष्पादन करता हुआ अग्रसर है अपने उद्देश्य कक्षा की ओर। इसमें इस चरण में UH-25 तथा N2O4 ईंधन का प्रयोग किया जाता है। यह विकास इंजन द्वारा संचालित है। इस चरण का कुल प्रज्वलन काल लगभग 150 सेकंड का होगा।
Cryo stage start authorized.
जैसा कि हमने पहले बताया था, द्वितीय चरण
Second
प्रज्वलन
stage
के दौरान
performance
ही
normal.
तृतीय चरण को अनुमोदित कर दिया जाएगा।
There is a confirmation of the authorization of the third stage or the cryo stage
GS2 thrust cutoff.
operation. The
GS2
second stage
separate.
has completed its
Stage ignition
operation and has
commanded.
been jettisoned from the ongoing vehicle.
द्वितीय चरण के सफलतापूर्वक प्रदर्शन के पश्चात
Cryo
उसे
stage
यान से
ignition
पृथक कर दिया
confirmed.
गया है और तृतीय तथा अंतिम चरण का प्रज्वलन शुरू हो चुका है। यह बहुत ही जटिल चरण है। इसके साथ ही दर्शकों का उत्साह, यह अंतिम चरण है जो उपग्रह को उद्देश्य कक्षा की ओर ले जाएगा।
The cryogenic upper stage has commenced its operation.
Cryo stage operating at uprated level.
The CUS stage with CE 7.5 engine with liquid hydrogen as fuel and liquid oxygen as oxidizer with a nominal thrust of 73.55 kilonewton. In this mission, there will be a thrust upratement of 11%, that is
Cryo stage performance normal.
81.64 kilonewtons for about 405 seconds.
+6 minutes.
वर्तमान में तृतीय चरण क्रायो अपर स्टेज कार्यरत है। इस दौरान यह लगभग 75 किलो न्यूटन का प्रणोद उत्पन्न कर रहा है। यह चरण लगभग 850 सेकंड्स तक जारी रहेगा। वर्तमान में सापेक्ष गति 3.49 किलोमीटर प्रति सेकंड तथा ऊंचाई 514 किलोमीटर की हो चुकी है।
Cryo stage performance normal.
Altitude of 528 kilometers. Shar and Trivandrum stations continue to extend tracking and telemetry support. When the cryo stage had commenced action, the instantaneous relative velocity was 3.5 kilometers per second. While the end of thrust upratement, it becomes 4.5 kilometers per second. For the next 400 seconds that follow, there is a significant addition in the relative velocity of up to 7.5 kilometers per second.
Cryo stage performance normal.
सभी विशिष्ट वैज्ञानिक यहाँ उपस्थित इस घटना के साक्षी बनने के लिए। तृतीय चरण का निष्पादन पूरी तरह सामान्य। इस दौरान भू स्थित रडार स्टेशंस शार तथा त्रिवेंद्रम इसे भलीभांति ट्रैक कर रहे हैं।
The altitude gained during thrust upratement is about 400 kilometers in cryostage operational regime. When the thrust upratement ends, there is a considerable increase in relative velocity at a marginal loss of altitude.
+8 minutes.
तृतीय चरण की यात्रा लगभग 850 सेकंड्स तक जारी रहेगी। इस दौरान आपको उपग्रह के बारे में कुछ जानकारियां उपलब्ध करा सकते हैं। नासा इसरो सिंथेटिक एपर्चर रडार, जिसे संक्षिप्त में नाइसार कहते हैं, वैज्ञानिकों को प्राकृतिक खतरों और विनाशकारी घटनाओं जैसे भूकंप, ज्वालामुखी विस्फोट और भूस्खलन जैसी प्राकृतिक घटनाओं को बेहतर ढंग से समझने के लिए मदद करेगा। उपग्रह की बादलों को भेदने की क्षमता के कारण यह तूफान और बाढ़ जैसी मौसमी आपदाओं के दौरान त्वरित व सटीक जानकारी उपलब्ध कराने में सक्षम होगा, जिससे तत्काल प्रतिक्रिया समुदायों को मदद मिलेगी। यह बर्फ की चादर, ग्लेशियर और समुद्री बर्फ में परिवर्तन जैसे प्रमुख वैश्विक पृथ्वी अवलोकन को प्रदान करेगा। साथ ही वनों की कटाई, वनाग्नि तथा स्थायी रूप से बर्फ से ढकी हुई जमीनों का अवलोकन करने में भी सक्षम होगा। यह एक अग्रणी मिशन है जो कि पृथ्वी की प्रतिक्रियाओं के बारे में वैज्ञानिक जानकारी का खजाना प्रदान करेगा। इन सभी वैज्ञानिक आंकड़ों के लिए लगभग 9000 किलोमीटर दूर वैज्ञानिक आपस में जुड़ चुके हैं तथा आपसी सहयोग से इस महत्वाकांक्षी मिशन को एक व्यापक लक्ष्य तक पहुंचा रहे हैं।
NISAR, or the NASA-ISRO Synthetic Aperture Radar, is a remarkable milestone in the Indo-US space ties. Designed on the I-3K mainframe bus, NISAR will render services for the next 5 years according to free and open data policy. NISAR provides a means of disentangling and clarifying spatially and temporally complex phenomena ranging from ecosystem disturbances to ice sheet collapse and natural hazards including earthquakes, tsunamis, volcanoes and landslides. ISRO has identified a range of applications of particular relevance to India that the mission will address, including monitoring agricultural biomass over India, monitoring and assessing disasters to which India responds, studying snow and glaciers in the Himalayas, and studying Indian coastal and near-shore oceans by monitoring annual changes in bathymetry along the deltaic regions, shoreline, and erosion accretion. The changes that Earth is undergoing in its ecosystem, deformation, and cryospheric sciences emphasizes the urgent and constant need to observe Earth from the vantage of space in order to thrive on our changing planets in decades to come. NISAR offers centimeter-level precision capable of detecting subtle ground shifts and environmental changes. Data from NISAR will provide critical insights to help India and US plan for natural and human-caused hazards. Today, when the GSLV F-16 rocket of ISRO places NISAR in its intended orbit, a critical deployment event, that is, of the 12-meter wide mesh reflector will take place. This mesh reflector acts as a radar antenna. The deployment will be a slow sequence to ensure the delicate boom and antenna unfold without damage or misalignment. The deployment will begin 10 days after launch and will be carried out over the next 8 days.
Plus 12 minutes.
To prepare NISAR for science operations, in-orbit checkout, physical deployment of all deployable parts, checking out the engineering systems, testing the radars independently and jointly. This phase will last for 90 days after the launch. Extensive calibration and validation activities will take place throughout the first 5 months. The schedule of science observations alone will be driven by a variety of inputs, including L and S band target maps, radar mode tables, and spacecraft and ground station constraints and capabilities.
तृतीय चरण क्रायो अपर स्टेज का कार्य निष्पादन पूरी तरह सामान्य। वर्तमान में सापेक्ष गति 4.9 किलोमीटर प्रति सेकंड तथा ऊंचाई 787 किलोमीटर की हो चुकी है। पृथ्वी की भूमि तथा बर्फ का अध्ययन करने के लिए सिंथेटिक अपर्चर रडार की क्षमताओं का उपयोग करते हुए माइक्रोवेव संकेतों को पृथ्वी में भेजता है और फिर सतह के से परिवर्तित संकेतों को प्राप्त कर 3D चित्र तैयार करता है। इसके लिए इसमें 12 मीटर व्यास वाले अनफर्लेबल रिफ्लेक्टर एंटीना लगे हुए हैं। यह उपग्रह 12 दिनों में 2 बार एक ही जगह से निकल सकता है और इस समय में चित्र में बदलाव से पृथ्वी में की सतह पर आए बदलावों का अध्ययन कर सकते हैं। नाइसार अंतरिक्ष यान नासा और इसरो द्वारा तैयार की गई सबसे उन्नत रडार प्रणाली वाला उपग्रह है। यह अन्य सिंथेटिक अपर्चर रडार की तुलना में अत्यधिक शक्तिशाली है। इसमें 2 रडार निदभार लगे हुए हैं। एक नासा द्वारा तैयार किया हुआ 25 सेंटीमीटर वेवलेंथ का एल बैंड रडार सिस्टम है तथा दूसरा इसरो द्वारा तैयार किया हुआ 10 सेंटीमीटर वेवलेंथ का एस बैंड रडार सिस्टम है। इसमें हर एक प्रणाली विभिन्न विशेषताओं के मापन में माहिर है, जैसे कि मिट्टी में नमी, सतह का खुरदरापन और गति। निसार सूर्य तुल्यकालिक कक्षा में काम करने जा रहा है। इसके एंटीना एक खास विन्यास में अंटार्कटिका का अभूतपूर्व अवलोकन कर सकेंगे। यह अंटार्कटिका के बर्फ की चादर, विरूपण और पिघलने के सटीक अध्ययन के लिए बहुत महत्वपूर्ण माना जा रहा है। नाइसार अंतरिक्ष यान दैनिक आधार पर सबसे अधिक डेटा उत्पादन करेगा। यह 3 साल के मुख्य मिशन के दौरान 100 पीटाबाइट डेटा उपलब्ध कराएगा, जो कि प्रतिदिन 80 टेराबाइट डेटा के बराबर है। इतने बड़े डेटाबेस के कारण इसे क्लाउड के माध्यम से संसाधित, संग्रहित और वितरित किया जाएगा। सभी एस बैंड और एल बैंड डेटा इसरो के राष्ट्रीय रिमोट सेंसिंग सेंटर NRSC के माध्यम से भारत सरकार के उपयोगकर्ताओं के लिए उपलब्ध किए जाएंगे। यह मिशन दोनों देशों के सिंथेटिक अपर्चर रडार की अनुभवी श्रृंखला को आगे बढ़ाने वाला है। नासा ने 1978 से CSAT से शुरुआत करते हुए तब से इन प्रणालियों की श्रृंखला ने विमान व अंतरिक्ष से विज्ञान क्षेत्रों के अध्ययन के लिए अग्रणी रहे हैं। इसी तरह भारत इन अनुप्रयोगों में विस्तृत श्रृंखला 2012 में रडार इमेजिंग सैटेलाइट RISAT-1 और 2022 में RISAT-1A की श्रृंखला शुरू की। नाइसार व्यापक स्वाद के साथ उच्च रिजोल्यूशन के डेटा निरंतर प्रदान कर सकेगा।
We are 16 minutes 15 seconds past the launch. Now the cryogenic upper stage is currently thrusting. The vehicle trajectory correctly follows the prediction.
Cryo stage performance normal.
तृतीय व अंतिम चरण GSLV Mark II का क्रायो अपर स्टेज के नाम से जाना जाता है। वर्तमान में पूरी तरह सामान्य प्रदर्शन करते हुए, सभी तंत्र सामान्य निष्पादन करते हुए यान को उद्दिष्ट कक्षा की ओर ले जा रहे हैं। कुछ ही क्षणों में कक्षा की स्थितियां प्राप्त करते ही क्रायोजेनिक इंजन को बंद कर दिया जाएगा।
The launch vehicle is at an altitude of 748 kilometers.
कक्षा की स्थितियां प्राप्त होते ही उपग्रह नाइसार को अंतःक्षेपित किया जाएगा।
Eagerly awaiting the satellite separation event.
Cryo stage performance normal.
Plus 18 minutes.
वर्तमान में सापेक्ष गति 7.35 किलोमीटर प्रति सेकंड तथा ऊंचाई 745 किलोमीटर हो चुकी है।
Stage performance normal.
The cryo stage is performing nominally.
Cryo stage thrust cutoff.
The thrust
Satellite
has been cut off
injection
of the
conditions
cryo
achieved.
stage, and next event is the NISAR separation, which is perhaps very close.
जी हाँ, जैसा अपेक्षित था,
NISR spacecraft separated. GSLV F-16 NISR mission accomplished successfully handed over to the mission director.
जी हाँ, इसकी पुष्टि हो चुकी है।
This is
प्रमोशन
mission
मिशन
director.
पे सफलता प्राप्त की जा चुकी है।
GSLV F-16 vehicle has successfully injected the NISR satellite into its designated injection orbit. The GSLV F-16 NISR mission is successfully accomplished.
History has been written today as NISAR has been placed in the orbit successfully. Many hearty congratulations to ISRO, NASA, and the users worldwide who will derive benefits of the Earth observation with this state-of-the-art NASA-ISRO synthetic aperture radar satellite. Do stay tuned. Tune in for the address by Secretary DOS and Chairman ISRO and mission executives. We take leave from you. Namaskar.
जी हाँ, इस प्रक्षेपण के साथ नाइसार का प्रमोशन मिशन सफल होता है। आप सभी दर्शकों और वैज्ञानिकों को हार्दिक शुभकामनाएं। आइए आप सबको इसरो अध्यक्ष डॉक्टर वी नारायणन तथा विशिष्ट वैज्ञानिकों के शुभ संबोधन के लिए लिए चलते हैं।
Either none. See as announced. Project director also, project satellite project. NASA. Please, sir, she's coming. Please, on. Very good evening to all of you. I am extremely happy to announce that GSLV F-16 vehicle has successfully and precisely injected the NASA-ISRO synthetic aperture radar satellite, NISAR satellite, weighing 2,393 kg into its intended orbit. Let me congratulate all the teams from ISRO and NASA JPL on this outstanding success. This is our 102nd launch from Sriharikota and the 18th mission of GSLV. As all of you may recall, we had the previous GSLV F-15 mission on 29th January 2025, which was the 100th successful mission launched from Sriharikota, and also the first launch after the new management, including me, took over as the chairman of ISRO. This is the first GSLV mission to the Sun synchronous polar orbit. Till date, all the GSLV missions have been to GTO. Being the first SSPO mission, several analyses and studies were carried out to make this mission a grand successful mission, including the cryogenic upper stage corrections. A host of mission simulations were carried out very systematically and meticulously, and today's successful mission is accomplished. All the vehicle system performance were quite normal, as expected and as predicted. And today, we achieved the intended orbit. Actually, we have got the orbit with a dispersion of less than 3 kilometers as against the permissible level of 20 kilometers. Perigee, the specification is 742 kilometers. We have got 740 kilometers. Apogee, 745 kilometers is the specification. We have got 747 kilometers. And all the parameters are as expected and in the right line. And this accomplishment is a teamwork, culmination of the teamwork of both ISRO and JPL NASA. The NISAR satellite is a significant milestone for both Department of Space and NASA JPL, being the first joint development project undertaken by the two major spacefaring nations. NISAR is an all-weather, day-night imaging satellite that will scan the entire Earth at 12-day interval. The satellite integrates ISRO's S-band synthetic aperture radar payload with NASA's L-band SAR payload and 12-meter unfurlable reflected antenna to become the first of its kind, a dual-frequency SAR satellite. NISAR will enable the scientific community to detect the surface variations, sea ice detection, investigate natural hazards, monitor soil moisture, and many other applications. The potential applications from the satellite are huge, and the global scientific community is eagerly awaiting the satellite data for their respective research and usage. The implementation arrangement between ISRO and NASA for a joint Earth observation satellite mission was signed on 30th September 2014. It was signed by the then Chairman ISRO, Secretary Department of Space, Dr. K. Radhakrishnan, who is sitting in front of us, and with the NASA Administrator, Mr. Charles Bolden. In fact, we were so happy to participate in that function which happened in Toronto. Since then, the realization of satellite in ISRO progressed steadily under the outstanding leadership of subsequent Chairman, Sri Kiran Kumar Sir, who is also present in the audience, Dr. K. Sivan, Dr. Somnath, and also under different project directors. On this occasion, let me congratulate all of them, also salute each and every one of the team members who have contributed for this significant achievement. Let me also congratulate all the technical teams, administrative teams both in NASA, JPL and ISRO, who worked shoulder to shoulder to build the satellite at UR Rao Satellite Center over the past so many years. The NISAR mission has brought the two space agencies much closer than ever before, and the continuous interactions at various levels during the course of project execution has enriched both sides. On behalf of Department of Space and ISRO, let me thank the NASA JPL team and all other stakeholders in the project for their excellent contribution to the joint mission. Also congratulate them on the successful launch. We wish the scientific community from both sides the exciting days ahead. Let me also congratulate the ISRO teams from SAC, URSC, VSSC, IASU, IPRC, LPSC, ISTRAC, and all the teams involved in the payload development, satellite integration, realization of solid, liquid, and cryogenic stages, inertial systems, and the launch vehicle itself. Let me take the opportunity to congratulate the Chairman Launch Authorization Board, all the center directors who are with me. It's a teamwork done by ISRO along with the NASA. I express my heartfelt gratitude to the Honorable Prime Minister, Sri Narendra Modi ji, who was the Minister of Space, has provided outstanding, encouraging support for the entire project for its successful execution today. Also, let me thank Honorable Minister of State, Dr. Jitendra Singh ji, and the PMO officials. PMO officials who are working hand in hand with the Department of Space, and all our family members, entire team members of ISRO, and the academia and industrial participants who have contributed for this. I think at this point of time, this success is demonstrating a teamwork, a international teamwork between two spacefaring nations, and surely this data is going to be highly useful for the scientific community of the globe. And when every 12 days when the data is going to come, it is not going to be used by one or two countries. The entire globe is going to benefit out of this great accomplishment. And at this point, once again, let me congratulate all the team members, our family members, industrial partners, academia team, and the NASA team for the outstanding work. At this point, before I hand over to my team, let me invite Cassie Swales, Deputy Assistant Administrator at NASA, for expressing her thoughts on the journey so far in this joint outstanding mission. Madam, please, floor is yours.
So I am honored to be here today in the ISRO Mission Control Center. It's just truly been an incredible visit so far, and I have to tell you, I had an opportunity. I'm sitting next to our charge. It's just an honor to have you here, so thank you, sir, for being here. The former ISRO chairman, I looked at him right after the launch, and I said, so how does it feel to not be on console? He said, well, it's a different seat, so it's good to not be in the hot seat. So I'm glad you got to watch the launch and enjoy it. But on behalf of NASA, I want to congratulate all of the teams. It has been just an incredible decade culminating in this moment, from the technical collaborations, the cultural understandings, getting to know each other, building that team across continents, across time zones, missing nights, missing weekends with families, holidays. It is truly something that every single person in this room should be proud of. I am so proud. I was so proud to be out there watching this launch. Dragonflies flying above, it just picture perfect, and I could not be more proud of these teams. You know, and this mission, it's truly a pathfinder, not just in regards to our technical collaborations, because those are truly incredible. This Earth Science mission is one of a kind and really shows the world what our two nations can do. But more so than that, it really is a pathfinder for the relationship building that we see across our two nations, you know, across India, the United States, building upon decades of collaborations that already existed. And I cannot be more proud to be here representing the US and really representing the teams that have been working so closely behind the scenes to make this happen. I also want to thank, I saw, several family members, both, last night on the US side, I saw several family members here. So I want to thank the families. It's no small sacrifice seeing your loved ones work day in and day out on a mission that takes over a decade to build. So thank you for your support of the incredible, technical, talented people in this room. And I really, really cannot wait for continued partnerships as we go forward, building on Chandrayaan, Axiom 4, and now NISAR. So thank you. Congratulations. Go NISAR. Go India.
Directors of ISRO who are responsible are with me here. So let us start with Sri Thomas Kurian, who is the Mission Director and Project Director of GSLV for this vehicle. Yes, Mr. Thomas Kurian.
Thank you, sir. Good evening, India. Good evening, ISRO. Beloved Chairman ISRO and Secretary DOS, Dr. V. Narayanan, sir. Distinguished dignitaries, respected formal Chairman, Center Directors, the NASA JPL teams present here at Sriharikota, and those joining us online, the entire ISRO fraternity, and my dear fellow countrymen, a very good evening to all of you. Today, we witnessed a historic moment in India's space journey with the successful launch of GSLV F-16 NISR mission, the 18th flight of GSLV, and for the first time, this vehicle has been operated for a sun-synchronous polar orbit mission. I am proud to announce that GSLV has delivered its best performance, ensuring precise injection of NISR spacecraft into its designated injection orbit with remarkably low dispersion. This marks a significant milestone not just for ISRO but also for international cooperation in space, particularly the partnership between ISRO and NASA. The success of this mission underscores our collective technical excellence, operational discipline, and collaborative spirit. I take this opportunity to extend my deepest gratitude to our respected Chairman, Dr. V. Narayanan, sir, for his continuous guidance, motivation, and confidence in our team. I sincerely acknowledge the support from ISRO Center Directors and the various review forums for their meticulous reviews, insightful recommendations, and timely decisions, all of which ensured the smooth execution of this specific mission. This success is the result of immense teamwork and commitment. I offer my heartfelt thanks to the system development agencies across ISRO centers, our industrial partners, the assembly integration, facility, quality control, quality assurance teams, and the administrative and auxiliary teams who work tirelessly behind the scenes. To all my esteemed colleagues and the families, a big thank you. This achievement belongs to each one of you. Our best wishes now go to NASA and ISRO teams for the next phases, culminating in the placement of the spacecraft in its final science orbit, where it will begin a mission that promises to bring game-changing data for Earth science and disaster monitoring. Before I conclude, I would like to place on record my sincere appreciation to Vehicle Director Dr. M.B. Dhanasekaran, Associate Vehicle Director Srimati Asha Mary Matthew, Associate Project Director Sri Binny Matthew, and Deputy Project Director Mission Srimati A.V. Mercy, and all my core team members from GSLV project. Your dedication, technical rigor, and mission focus have been the cornerstone of this major accomplishment. Let this day inspire future generations and reinforce our resolve to push boundaries and lead in global space exploration. Thank you. Jai Hind.
We will hear from Srimati Chaitra Rao, Project Director of NASA-ISRO Synthetic Aperture Radar Satellite.
Namaskaram. Respected Chairman ISRO, all Center Directors, former Chairman ISRO, delegates from NASA and JPL, What a moment. I just can't speak words. It's an honor to be here today at this moment when NISR has been precisely placed into the expected orbit. It's really a moment that we have all been waiting for so long. On behalf of entire NISR team, I would like to express my heartfelt congratulations to GSLV F-16 team for giving us this milestone beginning in space. I'm happy to announce that the satellite is injected with benign rates of almost 0.2, 0.2 and 0.5 degree per second. Both the solar panels are deployed and NISR will soon attain the required Earth pointing attitude. NASA-ISRO collaboration mission has fructified into this scale of a space mission today from a concept to reality, not just because of ISRO, but with a great team led by Mr. Phil Barella and his team from JPL NASA. They have been wonderful partners and a really team working together. We have all witnessed that have worked together for the past 1 decade. SR and LSAR shall come into life after 20 days in succession to deployment of 9-meter boom and a 12-meter reflector. So the sweep-SAR technique is going to image the entire Earth and give us 240 kilometers of data with high resolution and has an enormous capacity to give the science fraternity a lot and lots of data. So we are awaiting the next phase of the mission is to get the science from NISR. I would like to thank the entire project team, both from ISRO and NASA. I can see all of them here. A big round of applause to you all. All the centers and areas who have worked towards achieving this goal, expert committees, review boards, members, gurus, mentors who have all supported us all through this journey of this 10 years. Director URSC, I thank you for the opportunity given to me to be standing in front of this esteemed August gathering today. Former project directors and program managers, we have landed at this juncture today because of the journey that you have started. A big thanks to you all. Last but not the least, I thank all the families who have supported and filled in our absence. Thank you all. Vande Mataram.
Now we will hear from Mr. Nilesh Desai, who is the Director of Space Application Center. The team with him is responsible for the realization of S-band synthetic aperture radar payload. Yes.
Thank you, sir. Chairman ISRO and all the dignitaries present here from ISRO, NASA, JPL, and all the other centers. Let me greet all of you on this great occasion. What a great beginning, I will say. Ending of one portion, beginning of other part. And I am very proud to say that the S-band sweeps are, the first time 2 sweeps are will be in the orbit. These 2 sweeps are developed by JPL, L-band by JPL, and S-band by Space Application Center, Antariksh Upyog Kendra, Ahmedabad. We are very proud for this association, and all of us have worked for day and night, and now it is the time for these 2 radars to work day and night. And I'm sure they are going to give us very good data, and a lot of applications are already being planned, and I wish all the best to all of you. Let me congratulate first the vehicle team, the project, for very successful launching, as well as satellite team and my team at Payload Center, at Space Application Center for very nice work. Wish you all the best for the next days. Thank you.
We have with us the Launch Authorization Board Chairman and the Director of Satish Dhawan Space Centre, Mr. Rajarajan.
Thank you, Chairman. Dear mentors, my dear colleagues across ISRO and across many places, and JPL NASA team. It's a very good mission and a very successful one to be able to put in the right orbit. And all the stages that were coming from different parts of India and getting assembled at SDSR with a meticulous plan and very good review in by all the systems and a very good monitoring system also put in place at SDSR has enabled for us to have a seamless launch campaign and have a successful mission. In a lighter vein, it seems now GSLV has become the new PSLV in able to put a SSPO mission also in very perfect order. Kudos to GSLV of coming of age and able to do it a very perfect job. It actually, the change is always is a mantra and we are able to adapt. And kudos to the GSLV team for making this happen, this SSPO mission. Many midnight oils are burned and make sure that this vehicle comes all right in all aspects. And I also have to thank Chairman ISRO for thinking of many other ways of looking at different angles and putting the review system in place to make sure that everything falls in place and we do a good job, that do a professional job. I also thank SDSR and all launch vehicle team putting up a professional job and the satellite team able to bring in the satellite in time and do a meticulous job wherever it is required so that we meet the deadlines kept and we had a very good day to have a very good successful launch. I think this is a beginning and we'll wish everybody to have very successful launch in days to come. I'm wishing you all the best. Thank you.
Now we'll hear from Dr. Unnikrishnan Nair, Director of Vikram Sarabhai Space Centre, the mother center of ISRO, which is responsible for realizing this vehicle.
Thank you. Good evening. Congratulations to all. Very impressive performance by GSLV F-16, which has given necessary energy to the satellite in terms of potential energy to take it to 745 kilometers and also to give 7.5 kilometers per second. So that is the primary role of GSLV. So GSLV compared with our other Indian launchers has certain significance. This is the only vehicle having liquid strap-ons. And this is the only vehicle that can fly with the two sizes of payload fairing, 3.4 and 4 meter. So deep appreciation to all engineers, scientists, technical and supporting staff for this stupendous achievement. We are so delighted to carry the NISAR satellite to its intended orbit. This mission is a testimony to the legacy of long-standing collaboration between two great democracies in the world, and also it's a beacon of hope for more collaborative ventures in coming years. Best of luck to NISAR for further successful satellite operations. Looking forward to a lot of science from this very unique dual frequency SAR satellite that will give data on the dynamics of Earth from landslides to climatic changes. Thank you.
We have with us Mr. Sankaran, Director of the URO Satellite Center, which is responsible for realizing this great technological complex satellite.
Thank you and good evening. Congratulations are in order for everyone for achieving this task, which was carried out for the last decade plus. Congratulations to the teams who actually did the work and all the other people who supported them from behind and the sides so that it all happens in time. As already Chaitra mentioned, the spacecraft has deployed its solar panels. The SADA has been rotated and power generation has started, and the spacecraft is in 3-axis stabilized condition with the star sensor in loop. So there is actually practically what was planned to have been done over the next 40-50 minutes has already been achieved, because the satellite was very benignly injected by the GSLV, so no effort was required to bring it to the 3-axis stabilized condition. So thank you Thomas Kurian and team for the precise injection of the NISR satellite into the orbit, and of course Chaitra and team for doing the last lap of this relay race. A number of project directors before had been running this race, and always the one who finishes the race will get the credit, and she has to run at super fast speed. So she has run at the super fast speed to complete this race, and we have now put the satellite in the orbit. The real work for all of us starts in the satellite center, as well as our friends at our tracking station and our friends at our National Remote Sensing Center, and of course